VLSI design flow is the structured step-by-step process used to design, verify, implement, manufacture, and test an integrated circuit, or IC, starting from system specification and ending with the fabricated and tested silicon chip. VLSI design flow is the complete journey of a chip, from idea to design to layout to silicon to final product. Here is the complete flow. 1. System specification. This is where everything starts. We decide what the chip should do, performance target, speed, power limit, area constraint, cost. Example: design a processor that runs at 1 GHz and consumes less than 1 watt. This is just planning, no design yet. 2. Architecture design. Here we decide what major blocks are needed, how blocks connect to each other. Example blocks: ALU, register file, cache, memory controller. Think of this like designing the overall structure of a building. 3. Microarchitecture design. Now we go one level deeper. We decide how each block internally works: pipeline stages, data path width, control logic. This is detailed internal planning. 4. RTL design, HDL coding. Now engineers write the design using Verilog, VHDL, system Verilog. This is where actual coding starts. We describe registers, combinational logic, state machines. This is still not hardware, just code describing hardware. 5. Functional verification. Now we check, does the RTL code behave correctly? We simulate the design in our laptop or computer. Verification engineers write test benches, apply inputs, check outputs, find bugs. If bug found, go back and fix RTL. This step happens many times until design gets perfectly correct as per specification. 6. RTL synthesis. Now the RTL code is converted into real logic gates inside the computer. The tool converts always blocks to flip-flops, assign statements to gates, output gate-level netlist. 7. Design for test, DFT. Extra logic is added so the chip can be tested after manufacturing. Example: scan chains, BIST. This helps detect manufacturing defects later. 8. Formal verification, equivalence check. Now we check, does the synthesized gate-level netlist match the original RTL? This ensures synthesis did not change functionality. Physical design starts here. 9. Floor planning. We decide where each block will sit on the chip size, power areas. Think of these as arranging rooms inside a building. 10. Power planning. We design power lines, ground lines, so that power reaches all parts of the chip properly. 11. Placement. All standard cells, gates, flip-flops, are placed on silicon. 12. Clock tree synthesis, CTS. Clock network is designed so clock reaches every flip-flop with minimum delay difference. 13. Routing. Now wires are drawn. Connect all gates, connect all blocks. This is actual physical wiring on silicon. 14. Parasitic extraction. After routing, we calculate wire resistance, wire capacitance. These affect timing. 15. Static timing analysis, STA. We check, does the chip meet timing? If not, fix placement or routing. 16. Physical verification. We check DRC, design rule check, LVS, layout versus schematic. ERC, electrical rule check. Ensure the layout follows manufacturing rules. 17. Sign-off. Final checks. Timing, power, signal integrity, EM/IR. If everything passes, ready for tape-out. 18. GDS2 generation. Tape-out. Final layout file is sent to the fabrication company. Now design phase is complete. Manufacturing phase. 19. Fabrication. The chip is manufactured on silicon wafer. Transistors are physically created. 20. Wafer testing. Each chip on wafer is tested. Bad chips are marked. 21. Packaging. Good chips are cut from wafer, packed inside chip package. 22. Final testing. Packaged chips are tested again. 23. Production release. Chip is shipped to customers. Now let's clear the biggest confusion: verification versus testing. Many students mix these two. Let's make it crystal clear. Verification happens before manufacturing, happens during design stage, done using simulation. Goal: check whether the RTL design works correctly. Example: you design an ALU. Verification checks if 2 plus 3 equals 5. 5 minus 2 equals 3. If wrong, fix RTL. Verification engineers use test benches, UVM, assertions, coverage. It is 100% simulation-based. No real chip exists yet. Testing happens after manufacturing, done on a real silicon chip. Goal: check if the manufactured chip has physical defects. Example: broken transistor, short circuit, open connection. Testing uses ATE machines, scan chains, BIST. Now we are testing real hardware. Final analogy: verification is checking the blueprint before building a house. Testing is checking the house after construction. Some terms might have gone over your head. That's completely okay. Don't stop or get stuck trying to understand everything in one go. Just move forward. Watch the next videos. As we keep building step by step, those terms will automatically start making sense. Learning VLSI is a process. Clarity comes with repetition. So don't worry, just continue.